Dear students, I'm trying to have a voice note for all the lectures from here onward so that I can interact with you better. So the first voice note is for the first class, that is the introduction to toxicology. So before going into the class as such, I will first introduce you to the lecture schedule. So please open the lecture schedule file, in which I have arranged all the theory as well as history, the pesticide use and pesticide industry. That is a brief introduction about the pesticide industry in our country. Then next, with respect to the classification of insecticide based on mode of entry in chemical nature. And the third classification is with respect to the insecticide resistance action committee, that is Iraq classification. Though it is given as a single class, it may take two classes, because if you have to understand about the Iraq mode of action, you have to understand about some basic functions of how the insecticide acts on each different what is the biochemical nature of the insecticide action. Then comes pesticide formulation, the principles of toxicology. That part, the fifth part, that is comprising four classes, that will be dealt along with the practicals. So I won't be dealing in the theory session, it will be dealt along with the practical sessions. Then we will go into the each group of insecticides, starting with the first group, that is organochlorines, followed by organophosphates, carbamates, synthetic pyrethriotes, phenylpyrazoles, neonicotinoids, JH analogs, ecdysone agonists, chitin synthesis inhibitors, ivermectin, spinosins, all the new generation pesticides till the 18th class. And from 19th class onwards, we will be discussing something related to other things, that is synergism, potentiation, joint action, etc. Then insecticide compatibility, selectivity and phytotoxic, that's a single class. Then plant resistance to insects, it may take about 4 to 5 classes and will be dealt a bit elaborately along with its resistance management strategies. Then insecticide residues and their detection. And the last session will be on insecticide. I will give only a brief outline with respect to this. So that is the theory part. And the practical part, that's mainly with respect to the how to identify pesticide formulation and how to calculate toxicity by probit analysis, that is how to carry out a bioassay and how to calculate it based on probit analysis, LC50, LD50 calculation, etc. Then different methods of bioassay, then mode of action of pesticides, all those things, residue estimation methods, pesticide appliances, calculation, visit to pesticide laboratories, etc. So regarding the references, the first reference, Finney, is mainly for probit analysis alone. The second reference, it can be considered as one of the best available Indian book with respect to toxicology nowadays, though it's not a perfect book, it doesn't encompass all the topics. H.C.L. Gupta, it's an outdated book. Then Yetro and Gill, that's a comprehensive molecular insect science, volume 5 and 6, that's a reference book. It's an extremely elaborate book. Maybe for PG students it may be a bit difficult, but with respect to the mode of action of insecticides, this is one of the finest book for reference purpose. Then the next one is Ishaya, Biochemical Sites of Insecticide Action and Resistance. That's for how the insecticides act inside the insect body. Then Ishaya and Degli, Insecticides with Novel Model. It's a small book, but it's very fine with respect to certain new molecules. Then insecticide resistance monitoring mechanisms and management method. Actually, it's a practical manual, but that is very useful with respect to insecticide resistance. And the next one is Fumio Matsumura, a book, that is a toxicology of insecticides. Up to about 2000, 2005 and all, it was considered as the Bible of toxicology. It's but there is no recent editions for that, so it's in age old book, but it's a comprehensive book without any new generation insecticides. That's the thing, but still it's valid. Then that's a book from NBA. The next one, Mohan Sir's publication, Fighting Pesticide Resistance in Arthropods. That's I have a copy of it, that is mainly with respect to pesticide resistance and management. The next is Perry, Yamamoto, Ishii and Rika Perry, that is Insecticides in Agriculture and Environment. That's also a good book. It's a small book, but it's good. Then the next one is Richard T. Rauschardt, that is Pesticide Resistance in Arthropods. This book is extremely good with respect to pesticide resistance. If you want to go into in detail about insecticide resistance and all, that is well and good. And the next one, Srivastava, it's an outdated book, don't refer it. The next one, Valen, Motor Sanchez and all, it's a recent book on global pesticide resistance. The last book, USJ, that is Simon J. U, Toxicology and Biochemistry of Insecticides. That is one of the best toxicology books for PG students now available. We have a copy in the library, or you can download it from online from any of the sites. So this is with respect to the course outline. So please go through it. Try to get as much references as possible. So let's start with the first class, that is Introduction to Pesticide Toxicology. Toxicology is one of the oldest branches of pharmacology. Pharmacology and toxicology is highly related. Whenever we tell about toxicology, this is mainly it's a dose-response relationship. So pharmacology is the same. What is dose-response relationship? So even in pharmacology, we usually refer pharmacology as drugs to treat human disease and all. So here also we are giving chemicals to manage diseases. So here in agriculture perspective, he will be using pesticide. It can be a fungicide, it can be a herbicide, or it can be an insecticide, and this is used for management of pest problems. It can be pathogens, it can be insects, or it can be weeds. So toxicology is broadly defined as the branch of science that deals with poisons. So you may confuse one thing, it is the oldest branch of pharmacology and it is dealing with poisons. How a branch of pharmacology deals with poisons? Basically, any substance, that is a phrase given by the person who is considered as the founder of toxicology, that is Paracelsus. His entire name is Theophrastus Bombastus von Hohenheim, but he is known as Paracelsus. Paracelsus says that whatever be the thing, it is a poison. It is the dose that differentiates a thing from a poison and a remedy. So I will repeat it. That's the dose that differentiates a thing from a poison and a remedy. So our age old saying is that even if we take amrit for in excess quantity, it can be poisonous in nature. So whatever it be the thing, നമ്മൾ മലയാളത്തിൽ പറയുന്ന അധികമായാൽ അമൃതം വിഷം. So amrit is considered something which can cure all the thing. But even if you take amrit in excess quantity, it can be considered as a poison. So that is the thing. It is the right dose that differentiates a poison from a remedy. I will take a simple example. All of you might have heard about warfarin. Warfarin is a rodent poison. You might have studied in your UG classes. So warfarin, it's a if you check it, it is a red labeled poison, but the low doses of warfarin is given for cardiac ailments in order to prevent blood clotting. As you all know, anticoagulants. Warfarin is an anticoagulant. That's a first generation anticoagulant. Then we have second generation anticoagulants such as bromadiolone. All of them are rodenticides, of which bromadiolone is the one which is widely used. So warfarin, which is an anticoagulant, will be is widely used, recommended by doctors for cardiac patients. So it is a highly poisonous thing. The dose, if you consume it as a higher dose, it can be detrimental to our life, but if you take it at the right dose, it is curative for certain ailments. Another example we can take is that of our common paracetamol, which is widely used by us for our fever, headache and all. Paracetamol up to about 3000 milligram per day is fine for a fully grown adult, but if it crosses 3000 milligram per day for an adult, it can cause kidney failure. So up to 3000 milligram per day, it's fine as a curative measure, or it's fine as a drug, but if it crosses 3000 milligram, it is a poison. So that's the thing, all substances are poisons, so there is none which is not a poison. Only the thing that differentiates a poison from a remedy is the right dose. So that is why toxicology is a branch of pharmacology. And the clinical drugs, as I discussed, it is therapeutic. That means it is can be used for curing illness at some dose, but it is lethal at higher doses. So one more thing is a toxicant which is toxic to one species or strain may not be toxic to others. A typical example is with respect to neonicotinoids. As you all know, neonicotinoids, for example, imidacloprid or thiamethoxam. Imidacloprid or thiamethoxam is highly effective for managing sucking pests, but it is not effective against lepidopterans. Similarly, diamides such as chlorantraniliprole, flubendiamide, etc. is extremely effective against lepidopterans, but it's not effective against sucking pests. So a poison or a toxicant or a chemical, it can be toxic to one species or strain, it may not be toxic to another. Another thing which we can example we can take is with respect to neem. We all say that neem is an effective botanical against most of the insects, but there are certain insects which has the ability to feed on neem as such. An example is Helopeltis, that is tea mosquito bug. Another one is termites. All these insects can feed on neem. So that is one example. Another thing is tobacco. Nicotine we use as a botanical, but Spodoptera can efficiently feed on tobacco leaves. So a toxicant which is toxic to one species or strain, it may not be toxic to another, because different species or strains has the ability to overcome certain kinds of toxicants. So it's not that if one chemical is poisonous to one species, that means it is poisonous to all the organisms. No, we can't say that. There is selectivity which is happening. So that's why we try to select an insecticide which can target our pest, but it should not cause any toxicity towards the non-target organism. So that's how pesticides are evolved. Earlier pesticides were broad spectrum in nature. That means it will kill almost all the organisms which is in the sprayed area. A typical example is our pyrethroids and all. If you spray a pyrethroid, say phenvaldirate, cypermethrin, dentamethrin, etc., it will kill almost all the living organisms in that area. But consider the new molecules such as imidacloprid, thiamethoxam, or flubendiamide or chlorantraniliprole. It targets only a specific group of insects. That means neonicotinoids on sucking pests, diamides on lepidopteran pests, etc. So these kind of targeted delivery of a pesticide will save the non-target organisms. So if the non-target organisms such as predators, parasitoids, pollinators, etc. are not affected, then those insecticides are selective in nature. That means it will target only certain species or certain strains of insects. So that is one kind of chemicals. Then certain compounds may not be not toxic, but when it is mixed with another compound, it can become more toxic, or it can be more, or it can impart more toxicity to the chemicals. A typical example that we can say is synergies. Synergies are those which doesn't have any toxicity as such, but if we add a synergist to a pesticide, it will enhance the toxicity of the pesticide. That we will discuss in the last part of this course. Coming to the next slide, and which we told, toxicology, it deals with the it's the science which deals with poisons, and this poisonous nature of chemicals can be acute or chronic in nature. So if you say about acute toxicity and chronic toxicity, a typical example we can say is with respect to a person who consumes pesticide from the bottle as such. Say a person takes a bottle of quinarphos or Ecalex, and if he consumes from that bottle in an attempt to suicide, it will cause acute toxicity. The effect will be felt immediately. But chronic poison is toxicity is another thing. Say if a person is exposed to a food, a diet sprayed with a pesticide, say the same quinarphos, a person is consuming rice, vegetables or anything which is sprayed with quinarphos, and the food products are commodity containing residues of quinarphos, and he is consuming a small dose of this quinarphos regularly through his diet, he is exposed to chronic toxicity. The effect is not felt immediately. The effect is felt only after a longer period of time. So that is chronic toxicity. Acute toxicity, the effect will be felt immediately, and it will be after consumption at a huge quantity. Chronic toxicity, if we are exposed to any toxicant at small doses for a longer period, the effect will be chronic. It is not acute. Acute will be immediate effect of a toxicant which is felt at a which is taken at a higher quantity. Then the toxicity can vary between age, genetics, gender, diet, physiological condition or health status of the organism. So that is in the case of insects, the pupal stages which are not active may not be that susceptible to insecticides, and certain typical example we can say is with respect to caterpillars and moths. Though caterpillars and moths which feed on crop which sprayed with the diamide, flubendiamide or chlorantraniliprole, can lead to stomach toxicity. That means if we spray the crop with flubendiamide or chlorantraniliprole, the larvae will start feeding on the sprayed leaf. Once the chemical enters into the stomach of the larvae, it will exert its effect in the stomach and it will cause mortality of the larvae. But a adult lepidopteran, can be a butterfly or a moth, which feeds on nectar, will not be affected. So the same species but different age or different stage, there can be difference. So usually farmers say that I have sprayed a chlorantraniliprole or a flubendiamide in rice field, but still I am seeing lot of moths flying over the field. But because it doesn't cause any toxicity to adults, it only causes the toxicity to the larvae. Then genetics, that is we'll discuss in detail in the case of resistance, insecticide resistance. Then gender, males and females, that there is a difference in the toxicity between male insects and female insects. Then diet diet all can also influence. So usually whenever we go for a bioassay, we used to go for, in order to ensure that the insects are uniform in nature, we use about starved insects. We will allow the insects to be starved for about 1 to 2 hours. Then because if the insects are well fed, there is a chance that the toxicity to the species may vary. The next one is the physiological condition of the insects. It can also affect, and the health status of the organism. And toxicity will vary in the route of entry, that we will discuss in the next class, how the insecticides enter into the insect body. So that was with respect to the introductory part. Then let's see about the history of toxicology. Just go through the slides. In the earlier period, from 2500 BC onwards, humans started using one or the other for managing insects. And earlier there was sulfur, the inorganic material, as acaricide and insecticide. And in 1200 BC, the Chinese started using chalk, wood ash, plant extracts, arsenics, all of the inorganics and botanicals. Then later Greeks and Romans started using sulfur, fumigants, oils, ash, etc. Then later on it became botanicals such as pyrethrum, tobacco, etc., soaps, whale oil, etc. And by the 19th century, it was mostly inorganic, such as sulfur, arsenicals, that is Paris green. Paris green is chemically copper acetoarsenate, so it is mainly arsenicals, fluorides, kerosene, and along with botanicals. And phosphorus was used in Germany in 1800s. Then carbon disulfide was used, petroleum products. And by 1873, that is a landmark year during which Othmar Seidler, the German scientist, had synthesized DDT. He synthesized DDT, but he was unable to foresee its potential as an insecticide and all. He synthesized it and he kept it as such. And later on, it was in 1938 only, it was its insecticidal properties was 1939, only its insecticidal properties were discovered. Then HCN was used as a fumigant, later on lime surface. Then came Bodomycer by Millardet, that is mainly as a fungicide. Then sprayer was discovered by John Bean. Then again another arsenic was used, lead arsenate, for management of gypsy moth. Chloropicrine, our tear gas, it was used as a fumigant. 1932, methyl bromide was used as a fumigant. And coming to the modern synthetic insecticides, dinitro compounds, thiocyanates, etc. were introduced in the 1920s and 30s. But it was in 1939 Paul Muller discovered the insecticidal properties of DDT. So though it was synthesized earlier by Othmar Seidler, its insecticidal properties were discovered by Paul Muller in 1939, and it was widely used during World War II for the management of certain epidemic diseases such as malaria, typhus, trench fever, etc. So at that time, if you have seen certain Spielberg movies such as Schindler's List and all, you can see certain visuals in which the Jews which are taken as prisoners during the World War, they are taken to the concentration camps and they will be dusted with a powder. You can see that visuals in that movie, and that dusting is done with DDT. So that was the time even soldiers were dusted with DDT, just like we dust our body with talcum powder. At that period, DDT was used to dust over the bodies of soldiers to get rid of certain insects which are transmitting typhus fever and trench fever. And later on in 1941, BHC was introduced, and later on by 1944 OP compounds, organophosphates, were synthesized by Gerhard Schrader. Actually, he is a German scientist. Almost all the OP compounds, the discovery was done during the World War II by Hitler's scientists, and it was mainly used for tested in concentration camps. You might have heard about gas chambers in which the Jews were held, and the gas will be released into that chamber to eliminate this Jewish population from the German area. So all this gas chambers were all fed with all these organophosphorus compounds. So most of the organophosphorus compounds which were later introduced into agriculture were synthesized during World War II by German scientists as a chemical warfare tool. So later on it was taken up in agriculture. Then 1940s and 50s, organochemicals, organochlorines such as aldrin, dialdrin, entrin were introduced. By 1947, carbamates was introduced. EPN, another organophosphate, was introduced. It's an extremely toxic compound in 1950. By 1950s to 1970s, synthetic pyrethroids. Scientists were trying to synthesize the chemically, artificially synthesized pyrethroids. The natural pyrethrins which we obtained from chrysanthemum was extremely costly in nature. So scientists were trying to synthesize in lab this natural material, and they were succeeded in doing that, but all the chemicals synthesized in the lab till 1970 were photo unstable. That means it cannot be used in an open situation, because once it is exposed to sunlight it will degrade quickly. So that was up to 1970. By 1952, malathion, one of the most commonly used insecticide, was introduced. 1958, carbaryl was introduced, the Sevin, which is not used nowadays. By 1950s and all, was witnessed widespread use of all these organochlorines and carbamates. And by 1962, the Silent Spring, written by Rachel Carson, cautioned all the world population about the ill effects of indiscriminate use of pesticides. So that was a landmark year, and that's a landmark book. And by 1967, junior hormone mimics was introduced. 70, it was BT. Though BT, the insecticide properties of BT was discovered pretty earlier, the formulations was introduced in 1970. And between 1970 and 77, scientists were able to synthesize photostable pyrethroids. I told you between 1950 and 70, those scientists were able to synthesize artificially the pyrethrin-like compounds. All of them were photo unstable. But between 1970 and 77, scientists were able to synthesize photostable pyrethroids, and all these pyrethroids are now widely used all over the world, especially for management of agriculture as well as household pests. The 1980s, ivermectins was introduced. 1990, by 94, 95 and all, neonicotinoids were introduced. With the introduction of neonicotinoids, the use of pesticides has changed dramatically. So we can say that the pesticides before neonicotinoids and after neonicotinoids, we usually say it as new generation pesticides and old generation pesticides. So neonicotinoids introduction was a landmark thing in pesticide toxicology, and later on several new categories of insecticides were introduced, and every year we are seeing newer and newer molecules. So this is how the pesticides evolved all through the years. This is a brief. If you go into any literature, you can see several things in between. I have taken only the landmark things. And coming to the Indian pesticide industry. If you see the Indian pesticide industry, we can see that India is the fourth largest producer of agrochemicals after US, Japan and China. So a large part of our production is meant for export. That means just like our pharmaceuticals, our pharmaceutical companies feed most of the countries. Just now we can say that the hydroxychloroquine, which is considered as a drug for treating coronavirus, is exported from our country. All our countries are waiting for our shipment. So just like that, we are a major manufacturer of agrochemicals, and we are the fourth largest producer, and the value of the agrochemical industry in our country is 5 billion US dollars, and whatever be the thing which we produce, 50% is consumed here itself and rest is exported. And of the total pesticide market, biopesticide constitute about 3%. And regarding the pesticide consumption, if you see literature from different periods, it varies from 0.3 kg to 0.5 kg, so it's 300 milligram to 500 milligram different literatures, but roughly it is 300 to 500 milligram per 300 to 500 grams per hectare. But see the consumption in other countries. US it is 4.58 kg per hectare. In UK it is about 7 kg per hectare, and China it is 13 kg per hectare. So still our pesticide consumption is extremely low. The pesticide production is 2,16,000 tons in 2018-19. That means of which about 1 lakh tons is exported and 1 lakh tons is consumed here itself. And though you might have studied that cotton is the crop which consumes most of the pesticides, recently that's changed, mainly because of after the introduction of BT cotton and all. Now paddy is the crop which consumes the most of the pesticides. That's not because of the increase in the consumption of insecticides, it's mainly because of the increase in the consumption of herbicides, because with the increase in the wages in our country, manual weeding is becoming more and more expensive. So farmers are slowly shifting towards chemical application, chemical weedicides, and it is followed by cotton 18 to 20%. And what is the scenario of pesticides in our country is, you can go to this website, the link I have given, that will be updated regularly. I have taken the latest update given in February. The total number of pesticides registered is 289, and 40 pesticides are banned, and 4 formulations. The pesticides as such are not banned, but the formulations are banned. That means a pesticide can have 2 or 3 formulations. An example I can suggest is chlorantraniliprole. Chlorantraniliprole, you might have seen 2 formulations. One is Fertera, that is granular formulation, and the next one is SC formulation, that is Coragen. So if we are banning one formulation, that means if we are banning granular formulation, if we are allowing only SC formulation for use, that is the pesticide as such is not banned, but only formulation is banned. You can refer the site and which are all the I can check which are all the pesticides in which the formulations are banned and all. And the next one is there are certain pesticides which are allowed to manufacture in our country, but they are not allowed to market within the country, but the manufactured pesticides can be exported. Typical example is nicotine sulfate. We have a large number of farmers who cultivate tobacco. It's mainly for cigarettes and all, but from this tobacco, nicotine sulfate is extracted, and this nicotine sulfate is exported. That's mainly for pest management in greenhouses and all. And there are 8 pesticides which are withdrawn. That means if a pesticide company who has registered a pesticide feels that this pesticide need not be registered further, that means this pesticide does not have much value in the current market scenario, they can withdraw the registration. So like that, the companies has withdrawn registration for 8 pesticides, and for 18 pesticides the Central Insecticide Board has refused registration, maybe because of its high toxicity. And for 9 pesticides it is restricted use. And by the end of this year, the Central Insecticide Board has banned 6 more insecticide. That means they are permitted to be sold in the country only up to December 2020. So this includes one pesticide, that is dichlorose, which is widely used, that is banned. Then the next one is monocrotophos. I think I'll give the list later. So if you see the crop protection market in India, insecticides constitute 60%, fungicides constitute 18%, and herbicides constitute 16%. I told you biopesticides constitute 3%, and others means plant growth regulators and all. The part which is contributed by herbicides is slowly increasing every year. And the major pesticides consumed in our country, the first one is acephate, that's because of its wide use in rice. Then followed by chlorpyrifos, dinotefuran, fipronil, flonicamid, imidacloprid, glyphosate, quizalofop, weedicide, hexaconazole and tricyclazole. Tricyclazole is banned nowadays. Then if you see the state-wise consumption, Maharashtra is the state which consumes the largest pesticide, followed by UP and Punjab. And I've given the list pesticides banned for manufacture, import and use. I told you we have about 40 pesticides which is banned, that's the list. Then formulations banned for import, manufacture and use. Carbofuran 50% soluble powder. Carbofuran, the Firidan, we all know about the granular formulation, but earlier there was a soluble powder formulation which is not permitted to import, manufacture and use. Methomyl 12.5% SL and 24% formulation is not allowed. Phosphomidone SL formulation is not allowed, but I think phosphomidone as such is banned by this year. So I told you about pesticides which are allowed to manufacture but not for marketing in our country. Nicotine sulfate and captopril, they can be manufactured, but their manufactured commodity should be exported. The pesticides withdrawn, that means the companies have withdrawn the registration, that is Dalapon, Ferbam, of which warfarin by 2006 it was withdrawn. The refused registration, that's mainly because of its toxicity. And restricted, that is aluminum phosphate, cypermethrin, that is mainly spoke generator, dasomet, diazinon. See DDT. Many of the persons think that DDT is banned in our country. No, it's not banned, it is restricted. It is restricted. It can be used in our country for public health purpose, and the use is restricted only up to 10,000 metric tons per annum. That means every year 10,000 metric tons is manufactured and it is used for public health programs, that's mosquito management and all. And only Hindustan Insecticide Limited, that means a government undertaking, can manufacture it. And while use of DDT in agriculture is withdrawn. Methyl bromide only under plant protection, plant quarantine office and all. Monocrotophos banned for use in vegetables. And see the pesticides which are banned by 2020. Dichlorose phased out by 2020. Phorate, phosphomidone, trichlorophos, triazophos, all are banned by 2020. The others were banned in 2018, of which diazinon, carbapenemol, phenethione, etc. were banned in 2018. And in Kerala, the state government has given a government order that pesticides, the following insecticides should be used should be sold in the market only with the prescription from agriculture officers. Those pesticides are carbosulfan, chlorpyrifos, cypermethrin, lambda-cyhalothrin, acephate, and 2,4-D. Government has banned certain. Kerala government has banned certain pesticides such as glyphosate and all, but that order was overturned by the court, so that order doesn't stand now. So that is with respect to the first class, that is introduction. So go through the materials provided and go through the slides. If you have any clarifications, please